friends, welcome to Tech Simplified channel. Today's lecture I am going to explain Diffie-Hellman Key Exchange algorithm and its implementation in Python language. Okay, so let's understand what is Diffie-Hellman Key Exchange algorithm. So it is a cryptographic method and it allows the two parties to securely share a secret key over a public channel, and it is first published by the Whitefield, Diffie and Martin Hellman in the 1976, and it is the foundation of many modern cryptographic protocols. So what is the key idea behind the Diffie-Hellman key exchange algorithm? In this algorithm, two parties agree on some public parameters, that is a large prime numbers P and a generator G, and each party selects a private random number, that is a secret key. Then they compute their public values and exchange them, and using received value both calculate the same shared secret key. So what are the different steps in the Diffie-Hellman key exchange algorithm? For example, there are two parties, one is Alice and second is a Bob. So first, Alice and Bob agree on a public prime large number P and a generator G. Then Alice chooses its private key A and computes capital A equal to G raised to A mod P. Now the second party, Bob, chooses the private key B and computes capital B equal to G raised to B mod P. Now Alice sends A to Bob and Bob sends capital B to Alice. Now Alice computes the shared secret, that is B raised to A mod P, and similarly Bob computes the shared key, that is A raised to B mod P. These two keys are identical and it's considered as a shared secret key. In the practical implementation, we are taking an example of P equal to 23 and G equal to 5, and see that how shared secret key 13 passes between Bob to Alice. Now, what are the different applications of this algorithm? So, it is used in the secure communication protocols like SSL and TLS, and it is basis for the VPN and the encrypted messaging app. It helps to establish session key for the secure data exchange, and it is the foundation for the modern key agreement protocol. So now let's implement this protocol using Python. Now let's look at the server code. And to implement the Diffie-Hellman key exchange server code, we have to first import the socket library and then the random library. And we first defined the public prime numbers and the generator. For that, I declare one variable P, that value is 23, and generator G equal to 5. Now the server private key A is generated. For the server generates its private key A and compute its public key capital A equal to G raised to A mod P. Okay. Now we are starting server, and for that we use the socket library and bind the socket with the local host and the port number 5000. Now server is start to listening. Now I give a print message that server is waiting for the connection, and after that we are printing the connection and the address in the prompt. Okay. Now after connected, it sends a P, G and capital A to the client. Okay. So for that we are using connection dot send, and here I use a formatter P, G and A dot encode. Okay. Now after sending the P, G and A to client, the server is ready to receive message from the client, and for that it receives the B from the client, and now compute a shared secret key, that is B raised to A mod P, and print the shared secret key. Now close the connection and close the socket. So in this way we can implement the server side code of Diffie-Hellman key exchange algorithm. Okay, now after implementing the server side code, we are ready to implement the client side code, and for that we first import the necessary libraries like socket and random, and after that we have to first connect to the server. For that we are using the socket library and connect with the local host and the port number 5000. Okay, now the client is ready to receive the values p, prime number, generator g, and a from the server. Okay, and decode it, and after that we split these three values and store in our different variables. Now the client is ready to generate the private key, and for that it takes a variable v and generate a random integer between 1 to 10. Now the client generates the private key v and computes its public key capital B equal to g raised to small b mod p, and it send back to the server after encoding it. Now the client is ready to compute the shared secret key, that is a raised to b mod p, and print the client shared secret key. Okay, and now it's close the socket, and in this way we can implement the client side code of Diffie-Hellman key exchange algorithm. Now let's run the both the programs. For that we require two different terminals. So first we have to run the server side code. So for that, here I'm run this server side code. Now you can see that server is waiting for the connection. You can see that server is waiting for the connection. Now I start running this client side code. After running this client side code, we want to see that the client shared secret key is 2, and in the server side we also see that the client server shared secret key is 2. So both sides independently arrive at the same secret key without ever directly send it over to the network. So that's how we implement the Diffie-Hellman key exchange works using the Python sockets. We can now use the shared secret key for the encryption communication between client and server. And in real world systems, larger prime numbers and the secure libraries are used, but the simple demo shows the main idea. So thank you for the watching, and don't forget to like, share and the subscribe for the more cryptography and the Python programming tutorials. Thank you.